Hello, this is Lorraine Jamison, and this is the GoReact quiz number 3. So the first problem in this quiz is to use the method of reduction of order to find another linearly independent solution y2, then give the general solution. So the first problem was this one. Y double prime plus 16y equals 0, where y1 is equal to cosine of 4x. So in order to solve this one, you use the method of reduction. So first, y is equal to u of x, y1, so that's, I just called u of x u. So that's equal to u cosine of 4x, and then I found the derivative of y prime, and then y double prime. And so after I found y and y double prime, I just plugged it into the equation y double prime plus 16y. So this is y double prime, and then plus the 16y, which is u cosine 4x, so times 16 is u cosine 4x. And then these two terms canceled out, so you are left with u double prime cosine 4x minus 8u prime sine 4x is equal to 0. You set w equal to u prime and w prime equal to u double prime. And then you find the standard equation by dividing the first term by cosine 4x. So that gives you w prime minus 8w times the tangent of 4x. So your p of x value is equal to negative 8 tan of x, and you solve this using substitution. So I found the mu value, e to the negative 8 tan 4x is equal to e to 2 ln of cosine 4x. And then that 2 moves to square the cosine by the properties of logs. And then this simplifies down to just cosine squared 4x. And then you plug it back in to solve for the substitution. So cosine squared 4xw is equal to 0 times cosine squared 4x. And then you take the integral of both sides to get that cosine squared 4xw is equal to the constant c. So w is then equal to c divided by cosine squared 4x, and that is equal to u prime, or du dx. So you multiply both sides by dx, so you get c1 over cosine squared 4x dx is equal to du. You take the integral of both sides, so you get u is equal to c1 tan 4x divided by 4 plus c2. If you set c1 equal to 0 and c2 equal to 0, you get, c1 equal to 1 and c2 equal to 0, you get u is equal to tangent 4x divided by 4. And then plugging it just back into the y2 equation, you would get tan 4x divided by 4 times cosine of 4x. And then that just further simplifies down to sine of 4x over 4. So your final y2 value is sine of 4x over 4. And then in order to find the y value, you just plug in both the y1 linear equation and the y2 linear equation. So y is equal to c1 cosine 4x plus c2 sine 4x over 4. And then for the second problem, we had y double prime plus 2y plus y is equal to 0, where y1 is equal to x e to the negative x. So for this one, you can just solve using y2 is equal to y1 times the integral of e to the negative p of x dx divided by y1 squared dx. So I just plugged all the values in, where p of x is equal to 2, and so e to the negative p of x is equal to e to the negative 2x. And then I just plugged those values in. E to the negative 2x divided by e to the negative 2x, because this denominator was squared from here. So you get x e to the negative x times the integral of 1 over x squared dx. And so 1 over x squared dx, the integral of that is negative 1 over x. So the 2x's cancel out, and so you get for your final y2 value negative e to the negative x. And then that's the final y2 value. And then once again, the final y value is both the linear equations added together and multiplied by the constants, the arbitrary constants. So y is equal to c1 x e to the negative x minus c2 e to the negative x. Thank you.